Good afternoon, everyone. Thank you for being here for this presentation. So, before starting with the specifics of my dissertation, I would like you guys to imagine a scenario where you are working on a construction project and you have to deal with multitudes of file formats. Like if you are having the BIM models for the graphical and the geometrical data, and then you have the scheduling files from different software solutions like Microsoft Project or Primavera P6. And then you need to integrate both of these file formats into yet another third party software, and then you extract the data that you want. So the main goal for this thesis was to have something like a single file format that can have all the relevant information that is needed in the project management aspect. Uh, I choose IFC because IFC has all the entities that can uphold all the relevant information that is needed. In this thesis, the main terms were the role of BIM as a catalyst for improving QTO and cost estimation practices, and also checking the impact of modeling techniques on cost estimation procedures, which can boost the productivity and reduce the errors with the automated BIM workflows. Also, in this thesis, there is an advocacy for the open BIM formats, which is in IFC, and we are investigating the IFC entities, which is IFC cost item and IFC task for better cost and time information management. So before going further, we did a check on the modeling techniques, that what impact that the modeling techniques make on the models during the quantification. So we developed a tool for the calculation of formwork quantities using visual scripting tool Dynamo. The major task for this tool was to remove the overlapping surfaces and addressing the joint conditions with taking in consideration the critical thinking aspects. So to demonstrate the efficiency of this tool, comparative analysis was done, as you see on the screen. So these two models, this is the actual model, which is from Autodesk sample models, and this is the modified model in terms of the modeling techniques. So here we can see for the concrete, we don't see a much rise in the volume, but for the formwork area, we can see there is a significant difference in the quantities. Mm, these are some images which show like how the formwork quantification was impacted. If you see this image over here, you can see the formwork layer is going underneath whole slab. It is not taking in consideration the joining of this beam, but with the tool developed, these joint conditions were taken into consideration, and the precise calculation of formwork was done. The main goal was not eventually calculating the formwork quantities, but checking its compatibility with the open file formats. So we did an integration of IFC file inside Dynamo. So for this, we used tools like IFC OpenShell and Python OCC wrapper. So first we imported an IFC file into Dynamo using IFC OpenShell, and then we reconstructed the geometry inside the Dynamo environment, and then we applied the algorithm which was which was used in the previous slides to get the exact quantification of formwork. After having the precise formwork quantities, the next task was to add the cost related data inside the model. So for this, what we created a tool inside Revit using Revit APIs. The main task of this tool was to uh, to use the local price list from Bolzano region, and from that we can append the cost codes inside an element. So the functionality of the tool is allowing the user to link the multiple cost item to a single element. For example, like a column can be linked to various cost items such as formwork, rebarring, and casting. So this tool can help this tool can help to append the cost codes, multiple cost codes, to a single element. The previous approach before this tool was using Autodesk interoperability tool, but due to the limitation that only one single cost code can be assigned, so we need to develop this plugin for Revit. Once we have these cost codes inside our Revit elements, then the major task was to extract these into an IFC file. So for this, what we did is we created a custom property set. So we extract and embed the cost item codes into an IFC file, uh, and then which can be visualized in any IFC view. For now, it's in BIM Vision. After having the cost codes integrated into an IFC file, we needed to have the cost data from the price list. So so we developed a program using IFC OpenShell, which can read the codes from an IFC file, and then it matches it with the price list database. Once the codes are matched with the price list database, the additional information regarding the cost item, like unit rate, unit of measurement, and description of work, is extracted from the price list database and then stored back into the IFC file using IFC cost item entity. The next task was for to integrate the time related information with IFC task. So for this, we created a task template to incorporate time related data. We utilize IFC tasks to manage and integrate the time related information for each element in the IFC file. So the task template was developed in a hierarchical distribution, and the common tasks were identified for each element. For example, like a slab will have three tasks, which is rewiring, concreting, and the formwork installation. Then after the IFC task is being integrated into an IFC file, then once the IFC task has been integrated into the IFC file, then we make a common connection between IFC task and IFC cost item. As you see in this diagram, like IFC cost item has IFC cost quantities, which have their own attribute, which is IFC quantity value. And the task template which we developed in the previous slide, which is this, we have the IFC quantity values over here, like IFC quantity area, IFC quantity weight. So once these IFC quantity values from IFC cost item are matched with IFC task, then the cost item and the IFC task are linked together. Once we have like the IFC task and we have a related quantity to it in our IFC cost item, we can use simple quantity productivity ratios, which can generate the amount of time or the duration of the task, and then from which we can generate a planned schedule out of it. So for this, we divided the whole building into IFC building stories. For example, on the program process the IFC building story at the bottom level, and it goes through all the elements that are present on that building story, and then it checks the elevation, the top and the bottom elevation. Uh, the the element with the lowest bottom elevation is constructed first, and accordingly the whole schedule is generated. This is the entity relationship diagram, which shows the proposed methodology, how the cost item and the IFC task are interconnected in the proposed methodology, which can be seen detailed in the thesis. After we have the IFC cost item and IFC task inside an IFC file, we can extract the information from the IFC file, and we can visualize that data into the data visualization software. Here it was used Power BI. So Speckle was used to bring the 3D data inside Power BI, and these two, the task hierarchy and the cost hierarchy, these data are coming directly from the IFC file. So we can, without you having using the third party solution, we can use only IFC file to do such task. This would be beneficial in tracking the planned and actual progress of the project, and also in the progress tracking and updating the actual plans. This table shows the comparison of how the initial IFC file with no IFC cost item and IFC task data changes with the file size changes as we integrate the information inside an IFC file. So this file is having the lowest size KB, and after that the task is added into it. Then the task and cost, then the cost task and cost are linked together, and then task and cost are given a task time, and then these task times are updated with the actuals, so we can see the percent change from the initial. So now we talk about the limitation and the future work. So the main limitation is that it is discipline specific focus. We have just taken structural model into consideration. We haven't went into the architectural and MEP variabilities. Also, the time calculations for the task was done on the basic productivity ratios, which may not reflect the real world scenarios, and more intelligent algorithms needed for the calculation of time. For the future work, we can integrate the MEP systems and the architectural systems also inside this methodology. And a server hosted IFC model can be IFC model can be hosted on a server, and the actual dates of completion can be updated using the daily progress reports. Also, the extraction of the information from an IFC file can be done using converting the IFC data into vector embeddings and using the advanced NLP techniques to extract the data automatically. Uh, yeah, so this is what was done for the thesis. If you guys have any question.